Hello students, let us now study further into more results of limits and the related problems. In my previous video, I had discussed the limits of trigonometric functions and we had basically studied limits of the kind limit x tending to 0 sin x over x, limit x tending to 0 tan x over x, limit x tending to 0 1 minus cos x over x squared, and limit x tending to 0 1 minus cos x over x. In each of these cases, we have studied limit x tending to 0 and then done the needful. Now suppose we have, now in the exercise 13.1 we have a question like question number 15, which says find limit x tending to pi sine pi minus x over pi times pi minus x. We have done the result for limit x tending to 0 sin x over x, whereas over here we have x tending to pi, something to do with sin x upon that angle. Okay, now if you just observe carefully, if you put x tending to pi, it is sine 0 over 0, which is 0 by 0 form. Now here what we do is, now whatever x approaches to, like x is approaching pi, so what we do is if you take this pi to this side, what do you get? X minus pi approaches 0. So let us put this as t, so that as x tends to pi, t tends to pi minus pi, that is 0. Now, so the given limit will become t approaching 0. Now sine, in place of pi minus x, if x minus pi is t, pi minus x would be minus t. Upon pi remains as it is, again you have minus t, which can be written as limit. Now pi is being a constant, can come outside. Now limit t tending to 0. Sine of minus t is minus sine t upon minus t. This minus and this minus gets cancelled. This becomes limit 1 upon pi limit t tending to 0 sine t over t, which is the standard result and which gives us 1 upon pi times 1, which is 1 upon pi, which is the answer. So we have seen that in case, mostly the results which we have done are as x approaches 0. But in case you get a question where x approaches a point other than 0, so what we do is we substitute it with a variable such that that variable approaches 0. Similar is question number 22, which says that limit x tending to pi by 2 tan 2x over x minus pi by 2. Again here it deals with tan. Now when you put x approaching to pi by 2 over here, this is tan pi over 0. Tan pi is 0, so 0 by, this is also 0 by 0 form. But still it is not in this form, that is tan x over x, limit x tending to 0. So let us now try to convert it to that known form. So again here put x minus pi by 2 as t, so that as x approaches pi by 2, t approaches 0, and this limit gets converted to t approaching 0 tan of 2 times, now x will be equal to pi by 2 plus t upon x minus pi by 2 is t. This gives us, this is equal to limit t tending to 0. Now this is tan of pi plus 2t upon t. Now this is tan of pi plus any angle is equal to, it's in the third quadrant positive, so tan 2t over t. Now to be able to apply this result, we should have the same denominator as the argument of tan. So multiplying and dividing by 2. So you have 2 and 2 here. So that this becomes limit t tending to 0. 2 can come outside and tan 2t over 2t. As t tends to 0, 2t also tends to 0, and this becomes 2 times 1, which is 2, which is the answer. So this way we can do questions if a trigonometric function is defined at a point, then the limiting value is the same as the value of the function at that point. In case it is not defined, then we use any of the results done before and then find the limit. And in case the limit x does not approach 0, it approaches some other point a, then we substitute x minus a as t and then do the needful. Now let us come to a very important topic in this, which is the left hand limit and right hand limit. Now left hand limit is written as L.H.L and this is written as R.H.L. And as we had discussed before in the beginning of this chapter, now suppose you have some value a, and if x approaches a from the right, okay, then the value is so obtained, value of the function so obtained is called as the right hand limit and is written as limit x approaching a from the right. So we write a plus sign into fx. This is called as the right hand limit. If x approaches a from the left, the limit so obtained is called as the left hand limit and it is equal to, we write it as x approaches a minus. Minus indicates from values less than a, fx, and this is called as the left hand limit. A limit is said to exist if limit x tending to a, fx exists if left hand limit is equal to right hand limit at x equal to a. Now let us do a different kind of questions where we have to make use of left hand limit and right hand limit. All this while the whatever functions we considered, they were defined uniformly over the real numbers. Now though there are some values or some functions which are defined in a different manner on the left of a point and another manner on the right of that point. In such cases, we make use of left hand limit and right hand limit. Like for example, let us take question number 23. The question is defined as fx is equal to 2x plus 3 when x is less than or equal to 0, and it is defined as 3 times x plus 1 when x is greater than 0. Now we have to find the limit x tending to 0 fx and limit x tending to 1 of fx of this function. So let us first consider now to find limit x tending to 0 fx. We proceed as under. Now what we observe is from the definition of the function, on the left of 0 there is one definition of the function, that is 2x plus 3, whereas on the right of x equal to 0 the function is defined in another manner, that is 3x plus 1. So let's see how we proceed. So let's first find left hand limit. That is different. We write it as x tending to 0 minus fx. Now what we do is we drop this negative sign. Instead, we replace the function fx by the definition on the left, that is 2x plus 3. And now we evaluate like a regular limit and it comes out to be 2 into 0 plus 3, which is 3. This is the left hand limit. Similarly, to find the right hand limit, We proceed as under. We write it as limit x tending to 0 plus fx. Now, next step involves dropping this plus sign and instead replacing the function fx by definition on the right. On the right of x equal to 0, definition of the function is 3 times x plus 1. Now, substitute the value of x as 0. We get 3 times 0 plus 1, which is 3, equal to the right hand limit. We observe that clearly left hand limit equal to right hand limit equal to 3. Therefore, limit as x tends to 0 fx is defined and is equal to 3. Now let us observe how to find the limit of the function as x tends to 1 fx. Now this is to be found out, to find. Now here we have the definition of the function as 2x plus 3 when x is less than or equal to 0. It is equal to 3 times x plus 1 when x is greater than 0. Now we observe that here, if you just see, the function is defined, okay, in one manner on the right of 0 and in another manner on the left of 0. Here fx equal to 3x plus 1, whereas on the left of 0 it is fx equal to 2x plus 3. But here, instead of finding the limit at as x tends to 0, we have to find the limit as x tends to 1. Now, in the immediate neighborhood of 1, no matter how close 0 is, it doesn't form a neighborhood of 1. Neighborhood of 1 is this part, extreme close left point and extreme close right point of x equal to 1. Now, we observe that the function fx is defined in the same manner whether on right neighborhood or left neighborhood of x equal to 1. So there is only a single definition of x as x approaches 1 from either side. So left hand side, whether it is from left hand limit or the right hand limit, the value of the function to be taken is the same, and therefore we simply take limit x tending to 1 fx. We don't check the left hand limit and right hand limit separately because there is a single definition of the function on either side. That is, there is a single definition of fx on either side of x equal to 1. Therefore, limit x tending to 1 fx is simply equal to limit x tending to 1 on the right side of x equal to 1. X equal to 1 is on the right of 0, and so the definition is 3 times x plus 1. You substitute the value, you get 3 times 1 plus 1, which is 6, which is the answer. And so we get limit x tending to 1 fx equal to 6, which is the answer. Now let us do one more question to further make the procedure clear. Question number 24, we have to find the limit x tending to 1 fx, where fx is defined as x squared minus 1 when x is less than or equal to 1 and minus x squared minus 1 x greater than 1. Okay, so clearly we have to find limit as x approaches 1, and there are two different definitions. One on the right of x equal to 1, which is minus x squared minus 1, and one on the left of x equal to 1, which is x squared minus 1. So let's first find the left hand limit. Will be x tending to 1 minus fx. Now the next step involves dropping this minus sign and replacing the fx with the definition on the left, that is x squared minus 1. Now substitute x equal to 1 here. What do we get? 1 squared minus 1, which is 1 minus 1, which is 0. So we have left hand limit equal to 0. Now let us see what is the value of right hand limit. So we get limit x tending to 1 plus fx. Now the next step involved is you drop x, the positive sign, and instead replace the fx with function definition on the right, that is minus x squared minus 1. Substituting the value, you get minus 1 squared minus 1, which is minus 2. So right hand limit equal to minus 2. Clearly, left hand limit is not equal to right hand limit. It implies that the limit as x tends to 1 fx is not defined. In this manner, we can do any and every kind of questions whose limits have to be found out. Thank you.